I'm Jack Boulton, and welcome to the first development log for At the Will of the Gods. This video is focused on the game engine rather than the game itself, and provides an overview of my progress on the game engine over the past 2 weeks. Most of my development time over the past 2 weeks has been spent on designing the engine. I have written an ongoing document detailing my thoughts and ideas surrounding the engine, what its goals are, its core design concepts and principles, how it will be used, and what version 1.0 looks like. This has been written as a Google document, and I'm happy to share it. Check the video description for a link if you want to follow the development more closely. I also plan to create a Trello board for my tasks on the game in the future. In this video, I will talk a lot about code design and architecture for my game engine entitled Daxter. Firstly, I will explain what design and architecture is and why it matters in the context of game engine development. I will then deep dive into my past 2 weeks of work and talk through the design of Daxter, starting with its aims and objectives before moving on to the technology used and surrounding concerns. A look at interfaces and how they're used within Daxter, an explanation of the central pillar of the engine, and a look at the renderer, which is where most of my coding time has been spent over the past 2 weeks. With all the discussion done, we'll then take a look at a demo and what I've completed so far, with a nice look at how shader uniforms work in the engine currently. Don't worry if you don't have a clue what that means. I'll explain during the demo. A quick disclaimer before we start. I don't plan for this series of development logs to be heavily developer focused, but considering this video is aimed at the development of the engine, it's difficult to avoid. Strap yourself in, lay back, and let's get started. The first question you might have is, well, why have a design phase at all? And really, what is the design and architecture, and why is it so important? The easiest way to answer that question is to look at the job of the architect. If a building doesn't have a solid foundation, it will fail to support its own weight. This metaphor works perfectly in the world of code design and architecture, since badly designed software can become a nightmare to manage and maintain. The plan here is to keep things clean, tidy, simple and usable. Let's look at how I've designed Daxter to get a better idea of how design works in practice. The best way to start any project is with some aims and objectives. It's important to define exactly what we're trying to achieve. So let's look over Daxter's aims and objectives. Firstly, it's modular. This means that the engine is a collection of pieces that can be added, removed, switched out for others, and everything works. Secondly, it's lightweight, simple. This makes it a lot easier to understand and therefore ensures its ease of use. Thirdly, it's performant. This means it can run fast. I'm not planning on building the next God of War in terms of quality, but it needs to fit its purpose here. It's important here to mention the technology I'm using, since it will have an impact on the objectives. The engine and game will be entirely written in C#, along with a great graphics library called Veldrid. This manages communication between the processor and the graphics card, and allows the engine to support DirectX, OpenGL, and even Vulkan, meaning we can build games for Windows, Mac, Linux, mobile platforms, and even consoles using Daxter. I'm also planning on using another library called ShaderGen. This will allow for the writing of shaders in C#. This means we'll be able to write the game, the engine, and the shaders all in one language. It also means that we write the shader once and it works on all platforms rather than writing one shader for DirectX, OpenGL, Vulkan, etc. etc. The GitHub links to these libraries can be found in the description below. The final topic to mention is programming interfaces. The engine uses these heavily, and so I thought I would explain what they are before moving on. An interface is essentially a set of rules that something must abide by. An example of this would be, in order to be a car, you must have a method of steering, a method of accelerating, and braking, etc. Keeping that basic explanation in mind, let's move on to Daxter's design. The engine is designed as a collection of systems brought together by a central pillar. This is essentially a registration point for all of the underlying systems. Daxter's central pillar currently consists of the following systems: a window interface used to manage native windows, a renderer interface used to draw objects to the screen, more on this later, an assets interface used to load various resources from the hard drive such as textures, meshes, shaders and materials, an input interface used to capture user input such as mouse clicks and keyboard button presses, an audio interface used to play sound effects and music, and a scene interface which is used to define the layout of the viewable space. The key thing to note here is that while all of the systems have a defined job within the engine, they are all interfaces. This is the main way I'm meeting Daxter's modular requirement. From a user standpoint, as a game developer, when using the engine, you'll start an application with some configuration. This configuration will be used to define which of these interfaces are using the engine's default implementations and which are overridden, using an implementation of the user's choice. This works by using the power of interfaces. In order to be a window handler for Daxter, you must abide by the rules set by the engine's window handler interface. As an example, this might initially sound overly complicated, but really it's simple. The engine states a rule set that each of its systems must abide by and provides a default implementation for each of the systems. Looking at a simplified design diagram of Daxter design, we see four main elements. Firstly, the core design itself. This defines all of the system interfaces as described. Secondly, we see the systems and their relationships with the engine, and more importantly, their relationships with each other. They have no knowledge of each other and no means of communication. This is another important design decision made to ensure the engine is modular. Third, we see the conductor interface. This is a system used to manage all others within the engine. This is external from the core engine to ensure it can be overridden if required. Finally, we see the application interface. This is the system defined by the user of the engine and defines the game logic. If you would still like to know more, please see the Daxter design document. A link is in the description below. With the work completed so far, I've developed an early version of the renderer interface and implementation. The renderer dictates how objects are drawn to the screen. This is done in 3 distinct steps. Firstly, buffers are created with data defining what it is we're drawing. Secondly, those chunks of data are passed to the graphics card for drawing. Thirdly, we create a list of draw commands that use the previously defined data and buffers to draw objects to the screen. When drawing objects, Daxter uses shaders, materials, and render objects. Together, these objects define how things look. With all of that said, it's demo time. Let's take a look at what I've developed so far. Warning, it doesn't look like much at the moment. It's mainly design work, but it will make things a lot easier in the future. Here we have a standard rotating cube. This is defined by vertex positions in colours, along with index data for the order in which the vertices are processed to create triangles. This is using the shader, material, render object pipeline explained previously. The data is defined here along with the pipeline. Let's go through the process of passing data through the pipeline and using it to change how the object looks. First, we'll add a new variable to the shader code, paying attention to the type specified. Here, we're adding a color that we'll use instead of the vertex colors used previously. Once we've added the variable to the shader, called a uniform, we add a definition to the shader uniforms. This creates the linking point, allowing us to update data whenever we like. Once that's added, we simply use the generic method defined here to update the value. Here, we're setting the color to blue. And look, our cube is now rendering in completely blue rather than the vertex colors used before. This allows for massive flexibility while keeping things as simple as possible. There is still a great deal more to do, more systems to build, and the render is still incomplete. But this is some great progress and it's been a lot of fun. The plan of action for the next 2 weeks is simply to continue to design and define the engine. The goal being to have a working early version of each of Daxter's systems. Now, that was a lot of information packed into a short amount of time. Hopefully you were all able to keep up, and if not, my apologies. If you have any questions regarding the design of the engine, the game, or the information presented in this video, don't hesitate to comment on the video or message me on social media. I hope you enjoyed this week's development log. If you want to see more videos like this, please subscribe, and if you like this video, hit that like button. Thanks for watching, and as always, I hope you have a great day. See you next time.